Okay, today we're going to do properties of logarithms, and we are going to be expanding, condensing, and learning how to use our calculator with them. So the rules we have, we're going to start with a basic one that's not on here in the book. They have log base b of b equals 1. Okay, that's called the identity property. Yes, log base b of b equals 1. But this leads me into another part of it that if it was me, I'd remember this one, not the first one. Log base b of b to the x, which you guys were seeing last week, was just what? X.
Yeah.
So back over on this one, what's the exponent on this b that I didn't write? 1. That's why it's 1. So if I need to remember one, it needs to be which one? The second one, because the x is 1 over here, right? So when your bases are the same, your answer is your exponent, and you saw that over and over and over last week, didn't you? Well, at least over a couple times. So the next three properties you have, there are parentheses around these. They should be, put them in. The first one is called the product property because what are we doing with m and n? Multiplying. Okay. We are multiplying m and n. And so what do we do when we multiply exponents? What do we do with them? No. When we are multiplying exponents, x to the 5th times, we add them, right? So an exponential and logarithmic are inverses of each other, correct? So when we have log base b of m times n, it's log base b of m plus log base b of n. We're going to add them. All these stem from the fact that they come from the exponent rules. Well, what do we do when we divide exponents? Subtract. So our quotient rule is log base b of m over n equals log base b of m minus log base b of n. What do we do when we take a power to a power with exponents? Multiply. So our power property, we bring our exponent out in front of our logarithm. See that? So I have log base b of m to the n equals n times log base b of m. My expectation is by the time you're done with your assignment today, you know these 4 rules and can use them because you need to know them and use them to do tomorrow. Okay? There's 4. And this one up on top. Okay? So the purpose of your assignment is to use these over and over and over. So you need to show your steps so your brain sees those rules and can use them both left to right, basically, up and down. We're going to condense things and we're going to expand. From left to right is expanding. What's from right to left? Condensing. Okay, so you can use these rules from left to right or right to left is the goal today. And it's lagging. Okay, so the product, an example of the product rule would be log base 3 of 10. So is 10 a prime number? No. What's a prime number? 1 in itself. Okay, so 10 is what times what? Okay, so what do we do with multiplication? Well, not powers, we add them. We just add it. So it would be log base 3 of 5 plus log base 3 of 2. And if we needed, we can combine these rules too. If we had log base 3 of 3, then that would equal what? 1. So you can combine the rules as well. You're going to use more than one at a time. I'm just, that would be expanding it. And if I would condense, what is addition, tell me?
It is expanding.
No, what's addition? Multiplication. So I would take 5 times 2. 5 times 2 is 10. Okay, so we're going to go from the bottom to the top, top to the bottom. So then I have quotient. And these are just basic. Most of your problems won't be this basic. Log base 3 of 5 divided by 2. Well, what's division? Subtraction. So log base 3 of 5 minus log base 3 of 2. Oops, it's a 3. Yep, when you're expanding, yep. Now, you will have more, like I said, we're going to combine these rules. I'm just doing very, very basic ones. And then we got the power one, right? And I'm going to put power, well, we'll probably put, no, I was going to put identity with it, but that's pretty generic, pretty much basic what it is. Log base 3 of 5 squared. So where's the 2 go? In front. So it's 2 log base 3 of 5. Okay. No. It wouldn't be identity. I could throw the identity in if I had like log base 3 of 3 squared. Then you bring out the 2 and log base 3 of 3 is 1. Okay. So the next thing I have before we start this, this is like really laggy. Before we start this, I want you to make a note. You are not done expanding until there are no properties left and all numbers are prime. So you're not done until there's no properties left to use and all numbers are prime. So your quest on Friday, you're not done until what? Mm-hmm.
So no properties left and all numbers are prime.
Okay. So, like, if we had log base 3 of 10, that wasn't prime, was it? So we had to keep going. So first example we have is log base 5 of a squared plus b to the 7th. Well, they're exponents, so they're obviously prime. I mean, they're variables. See if I can make that bigger for you. Well, that was easier to read, wasn't it? Or no?
Ooh, presentation.
How's it look in the back? Garrett?
You have right. That might be
Good? Okay. Okay. So, what do I do? Let's see. I got to take it to this multiplication, right?
Yes.
So multiplication, we do what? Add. So log base 5 of a squared plus log base 5 of b to the 7th. Okay, are there any more properties left? Yep, which one? The power. The 2 and the 7 need to come out front, don't they? Only of what they're on, though. Not of the whole thing. So 2 log base 5 of a plus 7 log base 5 of b. Have I exhausted all my properties? All done. Everything's prime. Now, guys, when I say prime, I'm not talking about the numbers in front. Got it? Those numbers don't have to be prime. What you're taking the log of. Okay, so we're done. So what are we going to take care of here? What do you think we have to take care of first? I heard it. Quotient. We can't do the product until we take care of the quotient, can we? Just like any other problem.
What are those numbers?
R to the third and T to the fourth. Yes, it's a V. So log base 5 of R cubed times R to the fourth divided by V. So what do I do with division? Subtract. So log base 5 of R cubed T to the fourth, I'm going to take it in steps, minus log base 5 of V. So the log base 5 of V, it's done, isn't it? But this is not done. We've got exponents and we've got multiplication. So do you want to do that all in one step?
Yes.
Where are my exponents going to come out in front? In front of each individual one, right? So it's going to be log base 5 of, oh wait, it's going to be 3 log base 5 of R plus 4 T minus log base 5 of V. So when I go backwards with this, I need to look at it and what am I going to do first? My exponents, right? It's just like when I solve an equation, don't I do my order of operations backwards? Same thing. Okay, so I'm going to take care of my exponents first, and then I'm going to take care of my addition, yes? And it tells me this whole thing is added, multiplied, then it's all divided by V. Okay. So it says expand again. Log base 5. Evidently we liked 5s, but it's okay. We are going to use the quotient, aren't we? So it's going to be log base 5 of what? Log base 5 of 7. Log base 5 of... Okay, now what's my rule? I'm not prime, am I?
No.
So I need to break down 225. Well, 225 is not just a power of 5, is it? No. So how do you guys want to go? 25?
Yeah.
So how many quarters make 225? 9. I'm gonna owe somebody. If somebody said like 5, I'm gonna owe you 225, and I'm gonna give you 5 quarters. Okay, so yeah, I take those. So I've got 5 and 25. I got 9 and 25, right? So 25 is 5 what? Squared, and 9 is 3 squared. So I'm gonna break this 225 up, but I'm still dividing by the whole thing, right?
Yeah.
So what do you think I need to do there to make sure that negative goes to everything? I need to add a what? I got this negative right here. If it was addition, it wouldn't matter, but it's a negative, so what do I need to put there to make sure that I know it goes to everything afterwards? Parentheses, or I'm going to put a bracket just because we got lots of parentheses, but it doesn't matter. You could just put a bigger parenthesis, right? Okay. So now I know that that negative goes to everything else back here, doesn't it?
Yeah.
Okay, so 225, we already know it's 5 squared times 3 squared. So
2 log 5. Or, yeah. I don't know how to say it.
2 log base 5 of 5
Where'd you get the 2 at?
squared. This, we're coming right here. Plus, no. Well, we have the bracket here, so we can distribute that negative later if we want. Okay. Plus
2 log base 5 of 3.
Oh. Yeah.
Okay, nope, we're not done.
Bracket. Okay, that's what I did.
No, we're still not done.
I don't know what else to do then.
If you would have taken this in steps, you would have seen this right here was log base 5 of 5 what? Squared. What does log base 5 of 5 squared equal? 2. Because log base 5 of 5 is what? 1. 1 times 2 is 2. Do you see that? Okay, so we're not done because this is a property left, isn't it? So we're also, I'm going to show you we can distribute, well, I'll do it both ways, never mind. So log base 5 of 7 minus 2 plus 2 log base 5 of 3. Now, does it matter if the 2 is at the beginning of this or the end of this? It's multiplication, right? So I can do it either way. Okay. I don't care if you leave it like this. I'm fine. Sometimes you'll get a problem that looks like this, though, and you have to condense it. If they're both negatives, you're dividing by both of them, yes? So anytime I get repeated negative signs in a row, I factor those out and put them in a bracket because then I know they're all multiplied together, but then I'm dividing by it. Does that make sense?
Yes.
Because can't I go from here to here? Yeah. I can factor out a negative of just these two and it would look like this, wouldn't it? Yeah. So if I have to like condense this, because that's strung out, isn't it? This doesn't have a log base 5 on it, but does it really have one? Yeah, we have to remember that that was an exponent, wasn't it, of log base 5 of 5. So we go backwards then. But I don't care if you leave it like this or like this, either one. But if you don't distribute the negative, you have to have parentheses or brackets there because you're dividing by both. Got it?
Yeah.
Okay. So no rules, and they have to be prime, and this was the example of the prime, wasn't it?
So we can have either of those answers that we can.
Yes, either one of those answers is fine. I usually don't distribute the negative just because.
Like, so where did the log base 5?
This right here, because of our identity rule, when your bases are the same, it's your exponent. Because if I turned that into exponential form, I would have 5 squared equals 5x. Well, x would be 2.
Yeah.
Okay, now we're going to condense. And the way they say it is they don't say condense, and I probably will forget to write it the way they do, so I'm going to use condense because this is just weird. Because condensing is making it one logarithm. I guess they just tell you actually what you're doing. Write the expression as a single logarithm. So I need to go backwards. I need to go from bottom top. So your question is, where did things come from? How did it get that? Okay, so you got to go across. Well, any number in front of a log was a what?
Exponent.
Was an exponent. So I have 4 log base 4 of m plus 3 log base 4 of n plus log base 4 of p. So it was log base 4 of m to the 4th plus log base 4 of n to the 3rd plus log base 4 of p. Now what does plus mean? Multiply. So it's log base 4 of what?
To the fourth. To the third.
Wait, what am I doing?
I don't know. See how I went backwards?
I just skipped I skipped that middle that first step. It was my favorite.
I would suggest today not skipping any steps just because you need to know these really well for tomorrow. Because the better you know the rules today, the easier tomorrow will be. And then down here it says you're not done until there's no property left. And I guess you should also add you've multiplied everything out, right? Now, do I have to work out 2 to the 5th? Yes, 32. Do I have to work out 15 to the 5th?
Yes. Obviously.
Yes, in your head. Do the next one, yard. Garrett, what'd you get?
I'm not ready yet.
Oh, you're not ready yet? Okay. We'll wait.
You got it.
Hey, be patient.
I'm willing to tally a full-time job. Okay.
It ain't much, but it's honest work.
Callie, are you good? Okay, Garrett?
You want the answer?
Sure. You can just tell me well, yeah, go ahead and tell me. Step it through.
Well, 5 log base to a C if you know, the previous would be log to
Log base 2?
log base to the C to the 5th
Mm-hmm.
plus log base to N to the 7th. And then I just combine those and I got log base to C to the 5th and N to the 7th.
Yep. Okay. So today you're probably going to have to slow yourself down a little. I just need you to know these really good for tomorrow. Okay. Now, 2 more. They look a little different. Do you think I do them any different?
No.
No.
First one's good.
First one is division. You're right.
Genius.
Yep. Quotient property. And what? What other properties? There's one other property.
Natural log.
No, the power property.
Power property.
So the natural log of 2 cubed minus the natural log of 5 squared. So it's the natural log of 2 cubed over 5 squared, and you're not done. Am I done?
No.
I need to do those, don't I?
Yeah.
Okay, so it's the natural log of what? Over 25. Now I'm going to tell you guys something. When you condense, again, how many logarithms did I have left? I have 1, don't I?
Uno.
Anything, if they have the same base, they can be condensed. Can they be condensed if they don't have the same base?
No.
No. So then you might have 2 there. But please remember that, I hate to tell you, because none of you have done it, but I will see it, I'm sure. When I did this, there's 1 logarithm, and that 1 logarithm is on both. It is on 8 divided by 25, correct? It's not the natural log of 8 divided by the natural log of 25. It is 8 divided by 25, then your answer put into the natural log function, correct? What we're going to do next is what I just said, so don't do that. Okay, you got the next one done already?
No.
Well, try to talk.
Yeah, I do.
If I do.
Don't listen. Tips.
No. I appreciate you guys listening.
Do you want us to multiply it out?
Yeah, definitely. Anything squared, you should multiply out.
Yeah.
No, not the square. I mean,
Yes,
you can get out.
yes. It's just by 2. Yes, Ethan? Okay, what did you do? Step me through it. Uh-huh. That's 7 squared.
Plus natural log
Of 2.
Yeah.
Guys, those parentheses, that word is of.
I did it
Like,
right.
Thank you. We're not done. Then what?
natural log of 7 squared times 2.
Did you do 49? Did you just put it 49?
Yeah, I think so.
Okay.
And I got natural log of 98.
Because 49 times 2 is 98. See, I would have done 49 times 2, but it don't matter. Okay, we got this?
Yes, ma'am.
Okay, up and down, we can do it?
No.
So now you guys have been trying to get me to like let you put them in your calculator. So I guess I'll show you the change of base formula.
Oh, really? No, I'm fine. I'll just do it.
No, that's.
No, it's really easy. There's just a lot of stuff.
Hey.
Okay.
Is this on topic?
No, it's like there's a lot of prequel. It says, look, change of base formula. This is what this thing is called. It says positive numbers M, B, A, and B can't be 1. That's just pre stuff, right? Okay, so if I have log, okay, you ready? Okay, log base B of M. We can't put that in the calculator unless it's what two bases? 10 or E. Okay, so but we need to be able to do math with these things, right?
Yes.
Yeah.
Especially for tomorrow. So we're gonna do the change of base formula that takes log base B of M and puts it into. I hope you guys are writing this on your paper.
I am not. I'm
Log
trying to listen.
of M over log of B. What base just happened? It went from base B to base what?
Oh,
What base is this?
10.
10. So this is base 10. Or, it's a big or here. You could take natural log of M over natural log of B, and I can put that in my calculator, right? And that is base E. And I do expect you to remember that. I'm not going to tell it to you. Not very hard, right? Where's the base go? In the bottom. The of goes up top and the base goes in the bottom. With a newer calculator, I can put a different base in. But honestly, I never use it because this is so easy to do. This is not a hard formula to use, is it? No. I don't even bother with the buttons. I just do the division. So I have log base 2 of 3, and we're going to write it in both base 10 and base E. So in base 10, it would be what? Log of 3 divided by log of 2. In base E, it would be natural log of 3 divided by natural log of 2. And when you guys do that in your calculator, you should get approximately 1.58.
Oh, got that.
Why did it go?
Sorry, what are we supposed to do?
1.58.
5, 8, 4. Wow.
Okay, now I want you to do log base 2 of 7 by yourself. And I want you to write it both base 10 and base E. Either one works. If you put them in your calculator, you would get exactly the same thing. I promise you. See? Yeah, look, right there. 1.58, 1.58. See that?
That's what I have to do.
Well,
Got him. How is that the answer for that?
because it was all by calculator. But I'm really, guys, you're not going to have a calculator on the test.
Yeah.
So all I'm concerned about is you can set it up.
We already know that.
Probably not.
I'll sneak it.
Okay, Taylor, what's your base 10?
Base 10.
Mm-hmm.
I got log 7,
Of 7.
and then over log of 2.
Good job.
Taylor?
Callie, your natural log.
Natural log of 7 over natural log of 2.
Clark, your answer. So approximately 2.81. Thank you. You honestly just put log of 7 divided by log of 2. No.
Oh.
Yeah, make sure you end your parentheses because if you don't, you're doing a log and a log, and that's not what we're doing. Okay, the last thing, we have 2 more examples. And it's actually what you've been doing before. And so I'm going to put the examples up there, and I want you to start them like you would have done last week when I gave you these problems. Okay, we ready?
What happened last week?
Okay, last week when I gave you a problem like 2 to the x equaled 7 and 3 to the x equaled 15, what were you supposed to do?
I don't remember.
Switch it?
Change it into logarithmic.
I know.
So x equals what?
Log base
2 of
7
7, which is already there. And we couldn't do that. We left it like that last week, right?
Yeah.
Now we can do it. So what is x equal to?
7.
Well, but change the base formula.
9.
What are you going to put in your calculator?
Log
of 7.
divided by log of 4. And that is, what is it?
What's 2.81? We already just did it.
Yes.
Okay. So now you're not going to leave it like this. Even if I don't give you a calculator, you're going to go one more step and do what?
We're gonna change it to
That.
something else.
You're going to leave it so you can put it in a calculator. Got it?
Got
Okay.
it.
On your own. 3x equals 15.
Wow.
Done.
Well, I'm going to tell you guys, if you just give me answers, I'm going to not give you any credit.
2.46.
Do you have it change a base formula? Do you have it
I
in?
do.
Good.
I do. Miss Smith.
Austin, what's x equal?
No.
In this form, what's it equal?
X equals to log
Austin, you need to calm
base
down.
3. And total of 15.
Of 15.
Yeah.
And then what did you put in your calculator?
I put log of 15 divided by log of 3.
Did anyone use natural log?
No.
That's not what I said.
Would it give me the same answer?
Yes.
No.
It
It's
should.
not
Oh.
weird.
No, it better give you the right the same
Every
answer.
single time.
I just did it. It gave me the
What'd you
same
get, Austin?
What do you mean?
What'd you get?
Oh, 2.4649735.
Okay, so it's approximately 2.46
Yes, ma'am.
Why did you just erase 3 times?
because
What
I
if you did
didn't
one
like
and-
my approximately.
What if you did
What's
one
the point
natural
of
log
erasing?
and one and log?
No, you cannot. Okay, that's a good question, guys. You cannot have one in natural log and one in log. They have to be the same
Why?
because it doesn't work.
Yeah, it does. If there's the
Okay.
answer,
I'll show you.
Okay,
It gives you a completely different answer.
No,